All right, so today we're in the second section of the problem-solving module, and what we're going to be getting into with this one is really kind of the nitty-gritty stuff of the lean problem-solving methodology. You know, what it is, the individual steps, how we go through it, what that entails, what we're trying to accomplish with it. So, as a general overview, it's kind of an 8-step actual problem-solving aspect with the containment action added to it. So the first thing that we do is we want to be able to contain that problem. Stop flow out. We don't want to ship defects while we're still trying to figure out what we're going to do to solve the problem. So then on the back end, after we've contained it, we want to actually solve it. And this is kind of a list down of what those 8 steps are that we're going to be going through to solve the problem. So very first thing, kind of the containment action. What we want to do when a problem is identified is we want to walk the problem back upstream, and what that means is we want to start where the problem was identified. So it's at the end of the line, front of the line, middle of the line, in this building, that office, quality, you know, wherever it is, and then we want to go to the next upstream process. So who shipped it to the area where the issue was, that's where we want to go. And what we want to do is we want to look to see if the defect is there as well. And so what we're working towards is we want to make sure that each one of these processes stops shipping defective products or issues that or product or output that has this defect in it. And kind of the ultimate goal, the end point of the containment action is to identify where the problem is coming from. Where does it start? We found out where it was at the tail end or the middle end, but where is it starting from? Because that's where we want to focus. So one of the tools that we use for that, and this is included actually online, just a sample template for it, is we want to use just a sample containment plan. And this is just something that you can pull up, kind of fill out, practice with, but I encourage everybody, as with all of this, kind of the thinking is the key. There are some example tools like this provided, but feel free to use it and change it so that it suits your needs. That's what we're really trying to do with this stuff. So, as just an example of what would happen were there to be a defect in the real world, and we were going to go take a look at it. So, say we found it in area 4, the defect shows up. Let's walk it back, and at each place we walk it back, let's put something in place to prevent flow out. So, say we walk it back to step 3. We want to look at, is the problem here? If it is, what are we going to do in the short term to fix it, and how are we going to check to make sure that the fix is actually working? That's important too, the good follow-up. Let's say we walk it back to step 2, then we want to walk it back to step 1, and what we find in step 1 is we actually found the origin. So in this case, we could have found it at 3, walked it to 1, we could have found it at 7 and walked it to 2, it doesn't matter. We just want to go back upstream from where we find it to the point of origin. And at the origin, how are we going to fix it, and how are we going to check? Right, with the overall goal being stop the flow out, prevent it in the short term, because that's the #1 priority. So once we've got containment, so we're no longer generating these defects in the short term, now we can turn and focus our energy on how we're actually going to solve the problem that's creating this defect. And these are the 8 steps we walk through to do that. We clarify it, break it down, set a target, we do our root cause analysis, then based off that information we develop countermeasures, we put them in place, we check the results, and then when we have a successful result, we want to actually take it a step further and look at how can we standardize what we learned and what we did to share it with other areas, other people, other teams in the organization, so that as a company, as an overall organization, we're getting the maximum benefit out of all these individual problem-solving efforts, which is a little bit extra step, but in practice, there's a ton of value in actually adding that and following through with it. So for the first step, clarifying the problem. What does that mean? What do we do in this step? So the very first thing we want to do is we want to define and understand what is the ultimate goal that we're trying to satisfy by solving this problem. I like to kind of break it down into maybe 4 or 5 kind of different ultimate goals. Is it quality? Is it a lead time? Is it a cost? What is this problem related to? We need to kind of understand that so that we can put the rest of what we're going to do kind of in the right context. And that, if you think about it in terms of, if I told you or we decided this was a quality problem, you're going to start thinking about how to solve that a little bit differently than, say, it was a lead time or a cost problem, right? It just kind of helps put everybody on the same page about what we're actually looking to do by solving this problem. And it's one of the things that if we don't do it up front, you can run into some pretty serious confusion down the line, and I suspect a lot of people have some experience with that. So, ultimate goal, what's the purpose of our work? What are we trying to do here? So then kind of the next thing is we want to be able to understand and define what the ideal situation would be for this problem. Right? Is it 0% defects? Is it to make something half the size? You know, what would be in a perfect world if we were to solve this 100% completely? What would it look like? Then the next step is we want to be able to understand and define quantitatively, you know, not just, you know, in guess and descriptive terms, but quantitatively in things we can measure, because measuring is important. That's how we know if we actually solve the problem. How can we define our current situation as it relates to the ideal? So just as an example, say we had a quality problem and we found out that 3 out of 5 widgets had a defect. Well, in an ideal world, we want 0 widgets to have a defect. So our ideal situation would be 0. Our current situation would be 3. And what we find out of that, and the reason we want to do that is because we want to find what the gap is between our current and our ideal, because that gap is the problem we're trying to close. In that example with widgets, the problem here is that 3 out of 5 widgets have a defect. That's what we want to go after. So once we've clarified the problem, we find that gap, what we're actually going to try and close, then we want to start breaking down the problem. So again, what we'll find most often is kind of that gap from step 1 is a large, vague problem, right? Going back to just an example of widgets, there could be 1,000 different things that could be affecting the quality of that widget. So we want to start trying to break it down to see where that particular problem is coming from. So we start asking, you know, who, what, where, when, you know, how, why, man, material, method, machine. We consider all of these things. And so once we break the problem down to say we think it's coming from that area or this machine, we want to investigate, go and see, and we want to break that problem down again, right? Because we're trying to whittle that big, vague problem down through that funnel into little pieces that we can actually do something with. And so then the last thing out of this is once we kind of have this prioritized little piece that we want to go after, what we're really identifying is the problem process. And then we want to kind of break that process down. What are the individual steps in that process? You know, if it goes from here to there, and then what, you know, touches this machine and then that, because once we define the steps in that process, we can find the individual step where that individual piece of the problem is occurring. And once we find that point of occurrence, now we're in a position to start trying to ask why it's happening. So what it looks like if you kind of follow it is just down a tree. When we start with the big vague problem, we break it down, we break it down again, make it more manageable. We identify the process where it's coming from. We break that process down into the steps to find the small step where the small piece is coming from, and now we can do something with that. So I throw this in here to kind of explain breaking down a little bit further, because it's easy to say, hard to do, and it's one of the most challenging things to really kind of get the hang of and feel comfortable with kind of the first time through. So really what this means is, all right, so we've got our big vague gap, and what are we going to do? Well, we're going to start with brainstorming, looking at, you know, who, what, where, when. I say man, material, method, machine, just as kind of places to get started, questions to ask of what could be contributing to this problem, right? Answer those questions, where, who, what, man, material, and just brainstorm out a big list of what could be going on. Then what we want to do is we want to actually investigate that list. We don't want to just rely on our assumptions and guesswork. We want to go and see. We want to go see what's actually happening and talk to the people that are involved. And then based on that, we want to eliminate the causes that don't pan out, right? Because some of them won't be real or won't be that substantial. So we want to use our judgment, and we want to work to identify what we think is really kind of the meat of this problem, not all the other stuff. And then if you can't rule out everything, and that's oftentimes what happens, is you come down to maybe there's 2 or 3 things that are all kind of actually pretty important. What we want to try and do is we want to try and prioritize one of them using whatever data. So that would be, and we'll go back to our widget example, so say we find out that we've got a bad machine and that the operators aren't really trained on how to run the equipment. Well, what we would want to do is we would try and use our data or use something we can measure, because we don't want to just go on guesswork, to say, well, what's the biggest deal here? If we could perfectly train the person, would the machine problem still be bigger? Or if we fixed the machine but didn't train the people, would that not make a difference, right? So what's worse, the machine or the person? Because we only want to go after one by one problem solving. Let's find the biggest cause, and that's what we'll focus on. So once we do that, that prioritized problem, if we've done it right, should be a work process, right? So we say, okay, it's the machine. That machine, that's a work process. So what we'd want to say is, okay, well, what are the steps that go into the process of using the machine to make the widget? Do you open a guard and load the part and then turn it down and program a couple buttons and hit start, right? Those are individual steps. And we want to lay out those individual steps, start to finish, because what we're looking for is the element in there that's generating the defect. So in our example, say what we find when we go and see, the element is that when he goes to load, or he or she, when they go to load the part in the machine, maybe they're putting it in there crooked. We've found the point of occurrence. So we started with this big, vague problem. We have a quality problem. We understood, we whittled it down to our gap. It's 3 out of 5. We need to fix that. We started looking and we whittled the whole thing down from that big, vague problem to when the operator puts it in, they're putting it in crooked. Now we can do something about that. We can fix that. And we fix it, first step, by asking why. What's causing the problem? What's happening here? So, moving from that, now we want to set our target. So we know what's kind of the prioritized problem here. At the point of occurrence, we know what it is, but we want to set our target. And the reason we want to do this is we want to understand up front what we can expect to happen if we fix this. So for a target, it should really be by how much and by when, right? So we said our gap is, this 3 out of 5. Well, if we fix just the machine, because it was a machine and a man issue, do we think we could fix 2 out of 5, 1 out of 5, 2.5 out of 5? And how soon do we think we could fix it? 2 weeks, 1 week, 1 month? Right? And so I throw in these tips because this is something that can be a little bit of a sticking point sometimes. The target shouldn't always match the ideal, right? Because we're just focusing on one by one, small pieces. So we're not going to solve the whole problem all the time by just fixing one aspect of it. So we don't have to worry about that. We want to be accurate with our target. But we want to make sure, we want to check our target back against that ultimate goal. Does it match? So our target, if we meet our target, would that improve the quality in this case? If it didn't, say it would just improve the cost, then we missed the mark. We missed something. We need to go back and break the problem down again, right? That's a key point, and I just kind of want to make sure that comes across and that's clear. We want to double check the target to make sure that we're on the right track. The other thing we also want to do with the target is it should be a measurement of output. So, and I say that output as opposed to input. So it's not something we're going to go do. It ties into the second one, methods or will do statements. It should be kind of concrete, quantified output. So in this case, we'll cut the defect rate by 40% or something, right? Quantified measure of output. So when we look at kind of how to set a target, this is just something quick. We understand over time, we know our current condition, we know we want to get to some ideal condition. That's that total problem gap. Our target condition, again, is not always going to be the ideal. Remember, in this case, we don't think we'll solve the whole thing by just fixing that deal with the machine. But we've got our target gap. But through this problem solving, we're going to close that target gap. And then we want to try and get to the ideal condition with future problem solving activity, right? Piece by piece, one by one problem solving. Break it down, make it manageable so we can actually get a handle on this stuff and really start making some progress putting out all those fires. So, when you do this over and over, it sounds familiar because it's the basis of continuous improvement. So once we've got our target set, we've confirmed that we're on the right track. If we fix the problem we identified, it's going to match our ultimate goal. Now we can start asking why. So we start with that prioritized problem. We want to speculate causes, brainstorm, and then again, we want to go and see and investigate. What's really happening here? What's not a real cause? So rule out the ones that aren't real. Then we want to ask why. Well, we want to break it down again, brainstorm again, investigate those causes again, rule out the ones that aren't happening, and we want to repeat that process. Why? And the term 5 why analysis that I used in the last section comes from this part. Because as a rule of thumb, you really want to ask why 5 times to make sure that you've been thorough in your root cause analysis. Because it's easy to not go deep enough here and to stay at a shallower depth. And if you do that and you don't really get to the real cause, any solution you put in place is not going to actually address and solve your problem in the way that we anticipate, which is a problem, and it happens pretty frequently. So this is something that takes a little bit of practice. And then again, down at the bottom, we really want to try and only have one root cause. And that goes back to like what we saw in step 2, breaking down the problem. Maybe you'll have a couple root causes. Let's use some data, let's use our judgment, let's prioritize it, because we can really only fix one thing at a time. So the next step then, after we have our root cause, is develop countermeasures. And a countermeasure is really a solution. You know, what can we do that's actually going to fix this cause? So let's brainstorm. Let's consider all our potential options. We should be able to come up with a list of 4 or 5 different things. Work as a team, ask different people, bring in outside perspectives. It's important here not to keyhole ourselves into something that we're convinced is going to work up front. We want to be open, we want to be objective, and we want to be thorough with this, because this is a critical step too. If we don't come up with good solutions, we're not going to be able to solve the problem. So once we have all these ideas, then we want to choose which ones we're going to do. The ones that are going to be practical, the ones that are going to be effective. And we don't want to spend a ton of money on something that we don't think is going to work all that well, right? So then, after we've identified the countermeasures that we're going to pursue, then we want to actually build consensus, get the people involved that are going to need to be a part of this, and let's create an action plan for how we're going to implement these and how we're going to actually get from where we are now to putting the solution totally in place. And this is, again, where that communication aspect, that it's not my problem, it's the I can't control what they do. Building this consensus in this action plan and engaging the stakeholders, involving the people that have the scope of control to do this stuff, helps us break through that barrier. So then for step 6, it's pretty straightforward. See those countermeasures through. Let's check our progress. Let's make sure that we're following up. If we've got any obstacles, let's try and work around them. If we can't, let's get supervisors, let's get more resources, let's ask for help so that we can stay on schedule and we can meet our target. Step 7 then, after we've put everything in place, we've seen our countermeasures through, is we want to monitor these results. We want to confirm that we had good results, right? And that's pretty straightforward, because if we don't check our work and we just assume that it worked, how many times have we seen something like that put in place and then 20 years later people wonder why they're filling out a check sheet that has no merit, right? It's because we didn't check to see if it actually fixed the problem. We just assumed it did and moved on to something else. So when we monitor our results, we want to actually look at our target. Did we meet our target, right? That's why we set the target, so we can come back and we can measure our progress against it. I always suggest that we check and look at, did we meet our target, from a couple different viewpoints. From the standpoint of our end customer, did we solve it for them? From the standpoint of our actual organization, did we solve it company-wide? From the perspective of what's beneficial for the customer, what's beneficial for the organization? And then from our own personal viewpoint, did we do a good job of meeting this target from our standpoint? And then the last thing that we want to check when we're considering good results is how are we judging a good result? And what I mean by that is when we look at this little chart, there is a correlation between a good process and good results. So on the process side, going from bottom to top is a bad process to a good process. On the results, from left to right, bad results to good results. And what you can see with that big red X is if you have a bad process with bad results, we didn't hit our target. We want to go back, we want to rethink our countermeasures, we want to check and find out what we got wrong. On the other side, if we have a good process, but it gets bad results, that kind of top triangle, you know what, maybe we want to go back and relook at that anyway, because we must have missed something. If the process or our fix or our solution is working, but we just didn't get the results we wanted, what did we miss? What did we overlook? Let's go back and let's make sure that we get this fixed. Kind of as an extension of that is if we have good results, but a bad process, I always suggest that we try and go back and maybe tweak that a little bit too, because there's always the potential for luck when we go to check our results. If it's an unstable solution, if it's a bad process, there's always the potential that it was just luck that you got good results out of it that time. So what we really want to shoot for is that thing, this green circle in the top right, a good process that nets good results. That's really what we're after. If we can do that in step 7 when we go to confirm, we know we have a good permanent solution in place to this problem. And then that brings us to the last step, step 8. We talk about how do we standardize the success that we made in solving this problem and what we learned from here. How do we standardize it? How do we share it? And what that really looks like is, so for that implementation, we put our countermeasures in place, we confirm our results. One of two things is going to happen. Either it was successful and we can move on, or we didn't meet our target and we need to go back and look at it again. In that case of not meeting our target, we want to go back through the PDCA cycle, this plan, do, check, act, but it's just more or less that problem solving cycle. What did we miss? We want to kind of keep going back through it until we can drive that failure into a success, right? We don't want to stop trying to solve this problem until we actually get it solved. Otherwise, that's how fires keep popping back up. We throw some water on it, we turn around, and the fire pops right back up. So once we've been sure that we actually have good process, we have good results, now we want to standardize that. If we've done some temporary things, some tweaks, some experiments, we want to make permanent what we've put in place. And we want to make sure that when we do make that permanent, when we do standardize it, we want to make sure that anybody involved in the organization can use this and implement it and do it. And the 3 things I throw up there, muri, mura, and muda, it's just Japanese words, but overburden, inconsistency, and waste. So you're not asking people to do too much, or something that they can't. You're not asking someone to do something that's inconsistent or that's just not reliable or a robust process. And then the last thing, muda. Obviously, we don't want to put a fix to the problem that has a whole bunch of problems and waste in the fix, because that's kind of counterproductive. So then once we've done that, we want to start the next round of Kaizen, right? That idea of continuous improvement and Kaizen to keep closing that gap between where we got to now and our overall ideal situation. And this is, again, where it goes back to an iterative process. And so what you'll see, and I'll throw this in, is this word yokutan, which really just means share. So as we solve our own problems, and we make these improvements, and we improve the capability of our area and our team and our workspace, we want to share what we've learned across the organization so that other people can benefit and level up their workspaces and their teams and their departments in the same way. And as we do that, as we level up our own work and responsibility and improve our work environment, we also help the entire company level up and improve their capability as well. And the ultimate result of that is that we can drive the entire organization towards the ideal situation. And that's really kind of the key thinking out of this step 8, this last thing stuck to the end of this, is how can we maximize the benefit we get out of every little individual problem we solve. That's what we're chasing with this. So again, any questions, direct them through the website. I know this is, for this particularly, it's a little bit of information to take in all at once. It's one of those things where everything kind of can make sense as you follow along. Then you can turn around and wonder how in the world I actually put this into place. So the next section that we're going to get into actually looks at a formal example with a case study, where we'll use some of that sample documentation that I referenced, and we'll actually walk through how we do this stuff, how we break it down, how we organize our thoughts, and how we put this into practice. So I look forward to seeing everybody then.